Okay, so lesson 7.4 is about quadrilaterals. So we're moving on from triangles, which are three-sided shapes, to quadrilaterals, which are four-sided shapes. And this diagram shows properties of different types of quadrilaterals and how they're related to one another. So a quadrilateral at the top of the diagram is just any four-sided shape. But that can be broken down into three specific categories. Now, of course, we do have some quadrilaterals, which are just quadrilaterals. They don't fall into any of these categories. Like that shape at the top, it's really not anything other than just a quadrilateral. But then we've got some that'll fall into the category of a trapezoid. A trapezoid has four sides, and exactly one pair of the sides are parallel. You can't have two pair of parallel sides. If just one pair of the sides is parallel, you've got yourself a trapezoid. And then on the other side of the diagram, a quadrilateral with two pairs of congruent adjacent sides. So the two sides next to each other are the same size, and then the other two sides that are next to each other are the same size, and opposite sides are not congruent. So that would be a kite. And then we've got the parallelogram. And a parallelogram is a pretty common quadrilateral. It's got opposite sides that are parallel and congruent. Opposite sides, the same size, and they're parallel. Those can be broken into a rectangle. That's if all the sides are 90 degrees. Or a rhombus, if all the sides are the same length. And then if all the sides are the same length and all the sides are 90 degrees, then you've got yourself a square, which I like to call the perfect quadrilateral. You do need to remember these different classifications and the properties of each one. So for example 1, classifying the quadrilaterals. Well, that first shape, A, that quadrilateral has four congruent sides and four right angles. Also, opposite sides are parallel. You've got yourself a square. Now you might say, well, it's also a rhombus because it's a parallelogram and all the sides are the same length. You're right, it is a rhombus. You might say, well, it's a rectangle because it's a parallelogram and it's got 90-degree angles. You're right. You might say it's a parallelogram. You might say it's a quadrilateral. It's all of these things, but a square is the best name because it is the most specific. For part B, that quadrilateral has two pair of congruent adjacent sides, and the opposite sides are not congruent. So you've got yourself a kite, a pretty purple kite. The second key idea for this section is that the sum of the angle measures of a quadrilateral are always 360 degrees. Now, I don't often remember that, but what I do remember is that a square is a perfect quadrilateral, and a square has 90, 90, 90, and 90 for their angles, and that adds up to 360 degrees. So that way I can always remember that all quadrilaterals add up to 360 degrees. You have to be able to use this property to find some missing angles. In example 2 here, finding an angle measure, well, we know that all four angles have to add up to 360 degrees. So we add them all up. 70 plus 75 plus 115 plus x equals 360. We combine like terms to get 260 plus x equals 360. Subtract 260 from each side, and we get x equals 100 degrees. So, or not 100 degrees, just 100. X equals 100. We don't say 100 degrees because the degree mark is already up by the x. So the x itself is just 100. Now you try some.